Good morning, everyone. Welcome to Math Mondays. I'm Kayla Barnes, Math Coordinator for Kansas City Public Schools, and the segment that follows is kindergarten through second grade math. Hi friends, how are you doing today? This morning we are going to build on our knowledge that we started working on last week in regards to place value. So this week we are going to have a very focused lesson that stems from place value and goes into comparing numbers. So our objective today is I can determine 1 more, 1 less, 10 more, and 10 less than any number. So by the end of this lesson today, you should be able to think of any number and be able to tell me what is 10 more than that number, what is 10 less than that number, what is 1 more than that number, and what is 1 less than that number. Our tools today, we're going to be working with 2 different tools, base 10 blocks, which we started working with last week, and today we will also be using a hundreds chart in order to see some patterns in our observations. As you're working with me today, the only thing that you need is a piece of paper and something to write with, and then it's always important to have something near you that you can that you can utilize to help you count with. So I would recommend those 3 things. Take a moment now and let's get ready to learn. All right, so our first problem today, we're just going to pause here and I'm going to show you everything that is on the screen in front of you. That way, as we get working, you don't have any questions about what I'm grabbing or the format in which I'm presenting. So over here on the right in the blue section, you'll see my tools for today. I told you we'd be using a hundreds chart, so there's a hundreds chart. And we'll also be using base 10 blocks. So here's a tens rod, and here's a ones square in this case. So the first thing we are going to do is we are going to talk about the number that you see on your screen in the gray box. And the first number that we're going to start with today is the number 37. Okay? So as we're determining more and less than a number, the first thing I'd like us to do on this problem is model 37 using base 10 blocks. Do you remember how to do that? Here's a quick review. So as we look at the number, we think 30 and 7. So I'm just going to write that down. So I said 30 and 7. That makes 37, right? So remember that when we're talking about the number 30, that's the number of ones is that we will see in that number. But how do we take base 10 blocks and model 30 plus 7? So in order to model 7, 7's easy, right? We're just going to take 7 ones squares in this case, and we're just going to put them here. So there's 4, 5, 6, and 7. Great. Now I don't want to drag 30 individual blocks underneath the number 30. What's a different way I can model 30 using the base 10 blocks we have on hand? That's right. Remember that 1 rod equals 10. How many tens is in the number 30? Well, here's 10. Let's add another one and see if you can count by tens here until we get to 30. So here's 10, 20, and 30. Great job. So the number 37 is made up of 3 tens and 7 ones. And we've modeled it below using the base 10 blocks. Now what we have to do is calculate 1 more, 1 less, 10 more, and 10 less. So we're going to take that one step at a time. And on the left side of your screen here, you're going to see that I'm starting with 1 more than 37. Using our base 10 blocks, how can you model 1 more than 37? What would you add? A rod or a unit square? That's right. Let's use a unit square. So if we add 1 more to 37, add 1, what do we get? Well, 30 plus 7 we know is 37. Count on 37 one more time and we get 38. Good job. So I'm going to erase this part because now we need to talk about 10 more than 37. So I'll fix this block here and put it back. And now let's talk about 10 more than 37. So we added a 1's unit square to get 1 more than. Let's add a 10's rod to get 10 more than. So now we have 30 plus 7 plus 10 gets us to 10 more than 37. Well, what's 30 plus 10? That's right, you know 3 plus 1 equals 4. So 30, 3 10s, plus 10, 1 10, equals 4 10s, or 40. Good job. So we have 40, and then we have to add the 7 1s. That gets us 47. Great job. Now we have to talk about 1 less than. So we need to erase drawings first and put materials back that we don't need. When we talk about less than, are we adding or subtracting? Which one? That's right. When we talk about a number being less than, we're typically subtracting. So when we talk about 1 less, we're going to take 1 away from 37. That means down here with the unit squares, I'm going to take 1, I'm just going to put it off to the side, that way I know I've taken it away. We started with 37, and if you take 1 more away, that gets us how many? Good job, that gets us 36. And last but not least, the last thing we have to do, let's put this block back so that we get 37. Let's erase the minus 1. Now we have to calculate 10 less than. So when we were calculating 1 less, we took 1 unit square away. Now we're calculating 10 less. So what are we going to take away? That's right, let's take away 1 10's rod, or 1 10, because we know that 1 10 is equal to 10 1s. Now we have 30 plus 7, and we took away 10. What is the answer to this problem? 10 less than 37 is equal to what number? Well, 30 minus 10 is 20, plus 7 is 27. You did a great job on that problem. I know there were a lot of steps. Now we're going to move on to the second problem, where we're going to use a hundreds chart to see if we can draw some patterns and how we can do this quicker. So let's talk about the second problem. The second number we have is 72, and we have to calculate 1 more than, 10 more than, 1 less than, and 10 less than 72. And this time I'm going to use a hundreds chart. So I'm going to make it a little bigger so that it's easier for us to use. There. Now, the first thing that I'm going to do when I utilize my hundreds chart is I want to highlight the spot or the square where the number that we start with is. So I'm going to take my yellow highlighter here, and on the hundreds chart I'm going to find 72. And I'm looking down to where I see 70s, and then I'm going over 1, 2, and right there is number 72. Now, when we're calculating one more than, let's back up actually. Let's start back. Can you tell me how many tens and ones is in this number? Because we have to start there in order for this to make it easy for us. So when we model 72, you can build it with your base 10 blocks. You're going to find that you have 7 tens and 2 ones. Remember, the number on the left of a 2-digit number will always be the tens, and the number on the right will always be the ones. So we've highlighted 72 on our hundreds chart. Now we can talk about 1 more than, 10 more than, 1 less than, and 10 less than. So when we're talking about 1 more than, we need to take 72 and add 1 to it. On the hundreds chart, can you tell which direction I should move? Should I move to the right? Should I move to the left? Should I move up, or should I move down? Which direction will give us 1 more than 72? That's right, we know that 1 more than 72 is 73. And I can find that on my hundreds chart by moving 1 spot to the right. Now, if we're going to talk about 1 less than, we're going to skip 10 more for right now. We're going to talk about 1 less than 72. Take 1 away from 72 and you get 70. Let me undo that, change my marker. And you get 71. Now look at our hundreds chart. Which direction do we have to move in order to get to 71? To the left, up, down, or to the right? Well, we already had 73 to the right, so we know that 71 is going to be on the left. Great job. There's 2 more for us to do. Let's go up to 10 more than 72. So if you think really hard and add 10 to 72, you can do 72 plus 10, or we do know that 70 is 7 tens, and then 1 10. How many tens do you get? That's right, you get 8 tens. So if we take 70 plus 10, we get 82. Now look at your hundreds chart. Where do you see 82? Above or below 72? That's right, you see it below. Now the last step is to calculate 10 less than 72. That's your job today and this week. And I want you to keep practicing as hard as you can. And I hope that you have a great Thanksgiving and a great fall break. And I will see you after. It was my pleasure having you in class today. See you next week.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.
Good afternoon. My name is Christina Shields. I'm the math interventionist at Faxon Elementary, and I'm here today to go through a teaching activity on multiplying a 2-digit by a 2-digit number for 4th grade. Let's go ahead and get started. You will notice at the top of my screen, right over here in the red, I have put our learning targets for today. Our learning targets for today is following standard NBT A6. I can multiply a 2-digit number by a 2-digit number, and I can justify my answer using estimation. It's important that we use estimation so that we can try to make sure that our answer is not too crazy and that we are on the right track. So you will see that the method I am going to teach you today is partial products. This is just one of many different ways that you can multiply numbers. This one may work for you. You may really like it, and others you might like better, but I'm just going to teach you partial products today. So you see on my screen, we have two different types of problems. We have just a very basic solving answer, 59 times 16, and we also have a word problem that we are going to have to decipher. We're going to go ahead and get started with 59 times 16, but let's go back to that learning target, and one of the things that we want to do first is we are going to estimate what our answer is going to be. When I estimate my answer, I like to think of it in terms of a number line. And where is that number placed on the number line? I look at the number 59, and I know that it is in between 50 and it's in between 60. So I have to ask myself, is it closer to 50 or is it closer to 60? Yes, since it's at 59, it is almost 60. So we are going to go ahead and we are going to mark our answer as 60. It is about 60. The next one is 16. Again, I think about that number line, and I know that it is in between 10 and 20. Is it closer to 10 or is it closer to 20? Yes, 16 is closer to 20. So I'm going to go ahead and I'm multiplying. I'm so sorry, that does not look very good. I'm going to multiply 60 times 20 to give my estimate. I look at this and I see a basic math problem. The basic math problem that I see that I'm going to need to solve is 6 times 2. And I know 6 times 2 in my head, or I can count by 2's 6 times, 2, 4, 6, 8, 10, 12, and then I need to make sure I add my zeros on the end. So I have 12, and then I have my 2 zeros. So I'm saying that my answer is going to be somewhere around 1,200. It is not going to be exact. We just want to make sure that it's somewhat close. We don't want it to be really far off. We are now ready to go into partial products and how partial products actually looks. I break apart my numbers, and I work with the younger students on breaking apart numbers, and we break them apart based on their place value. So the number 59 is actually the same thing as 5 tens and 9 ones, and 5 tens is equivalent to 50. And then I have 9 ones. So 50 and 9 is my 59. I'm going to do the same thing with 16. I see 16 and I know that I have 1 10 and 6 ones. 1 10 and 6 ones. So I have 1 10 here and 6 ones here. 10 and 6 is 16. Now what we're going to do is we are going to work with inside of these boxes, and we are multiplying everything. We are multiplying each part of our problem. So we're going to multiply 50 times 10. 50 times 10. And I know that 50 times 10 is 500 because I have 5 times 1 and then my 2 zeros. So I have 500. Then I'm going to do 9 times 10. 9 times 10, 9 times 1 is 9, and I add my 0, so I have 90. Then I'm going to do 50 times 6. And where those two boxes meet, I have 5 times 6. 5 times 6, I know that's 30. And then 1 0. So 300. And then 9 times 6. 9 times 6 is 54. So you're probably wondering, what do we do next? We have done all of the multiplication. We have done all of that, so I must be done. You're not quite done. Now you are going to add all of the boxes that you have on the inside, everything that's inside of a box. So in this case, we're going to add 500. We're going to add 500. and we're going to add 300. I want to keep my place values lined up so that it is easier for me to add 90 and 54. And now you have your addition problem. So we start right here in this column, and I have 0 plus 0 plus 0 plus 4, and we know that that is 4. In the next column, I have 0 plus 0 plus 9 plus 5. 9 plus 5 is 14. So I'm going to leave my 4 here. And that's actually 14 tens, which is the same thing as 140. So we're going to carry that 1 over. We're going to regroup it here. And I have 1 plus 5 is 6. 6 plus 3 is 9. So you see here that I have my answer is 944. My estimate was 1,200. And since we are estimating, that is actually not too far off. We did round both of those numbers higher, which would give our estimate a higher number. So we can be assured that that is okay. If our answer had only been 244, we would want to rethink our estimate. We did something wrong. Okay, now let's move on to our word problem. It says Malik has been practicing his art skills by drawing superheroes. Each day he draws 34 characters. I don't know, I can even name 34 superheroes. How many characters will Malik have drawn after 25 days? I don't know about you, but that sounds like a lot of superheroes that he is drawing. So we are going to do the same thing. We are going to start by estimating. We are going to estimate how many superheroes he's going to draw. So he starts off with 34 characters every day. Is that closer to 30 or closer to 40 on my number line? Yes, correct. It is closer to 30. And then he does this for 25 days. 25 days. That's about how many days you're in school without the weekends. 25 days. Is that closer to 20 or closer to 30? And in this case, it is 30. So we are multiplying 30 times 30. You'll notice that one of our numbers we rounded down, one of them we rounded up. That is okay. We know that 3 times 3 is 9, and we add our 2 zeros. So we have 900. He is going to draw a total of 900 superheroes, around 900 superheroes, after the end of 25 days. He is going to be an expert. We are going to be experts in partial products. Let's go ahead and practice this again. So we're going to take our 34, and we want to break that apart into place value. 3 tens, 4 ones. 3 tens is equivalent to 30. And then our 4 ones. 30 and 4 is 34. And then we're going to break apart our 25 days. He has 2 tens and 5 ones. So therefore he has 2 tens is 20 and 5 ones. And now we're going to do just like we did earlier, and we're going to multiply every single one of those boxes and put our answers where the boxes meet. So 30 times 20. I see 3 times 2, and I am sure that 3 times 2 is 6, and then I have my 2 zeros, so 600. 20 times 4, 2 times 4 is 8, and then my 0. Finally, I have 5 times 30. 5 times 3 I see is 15. And I only have 1 0, so that becomes 150. And last but not least, 5 times 4. 5 times 4 is 20. We are now ready to add all of those up outside in the box and see if we are close to our estimate of 900. Let's see, we're going to add 600. 150, 80, and 20. All right, I'm going to add my ones column, and I have 0 ones all the way down. So I'm going to go ahead and leave my 0 here. The tens column, I have a 0 plus a 5 plus an 8 and a 2. I see that when I look at those, I automatically jump to 8 and 2, and I know 8 plus 2 is 10. 10 plus 5 more is 15. That is 15 tens, which is the same thing as 150, so we need to make sure we have 100 over here. 1 plus 6 and 6, or 1 plus 6 plus 1. 1 plus 6 is 7, plus 1 more is 8. So at the end of his 25 days, he is going to have drawn 850 characters. And we said, estimating that he was going to draw 900 characters. That is a very good estimate. All I know is that is a lot of superheroes that he is going to be drawing. That is all I have for you today. I hope that this has been helpful for you. Please let me know if you need any other help. I will talk to you later. Have a good day.
I am Lincoln Middle.
At Lincoln Middle School, students discover their talents and passions, where teachers plant the seeds of lifelong learning.
I am Lincoln Middle.
Where excellence is nurtured. Students develop the skills to be successful in school, career, and beyond.
Je suis Lincoln Middle.
Lincoln Middle is the public school where your child will thrive and grow. Open a world of possibilities. Apply today. Learn more at enrollkc.org/Lincoln Middle.
My name is Mary Jo Fender, and this is Math for Middle School. Today we're going to be talking about adding integers using a number line and algebra tiles. What you'll need for today is paper and pencil to follow along. Okay, take a few seconds and let's get ready to learn. When we talk about adding integers on a number line or even using algebra tiles, we first have to understand what is an integer. And an integer is a natural number. This is numbers that you counted with. This is what you learned in kindergarten and first grade. You start counting with 1, 2, 3. Those are natural numbers, and they're opposites. So if I have 1, my opposite is -1. If I have 5, my opposite is -5. 25, my opposite is -25. 75, my opposite is -75. You get the picture. And the number 0. Now, those 3 types of numbers, natural numbers, their opposite, and zeros, make up our integers. And most of the time you're going to see a number line that looks similar to this. It's either horizontal or it's vertical. Now, I prefer to draw number lines horizontally when I'm solving equations because it's just faster for me to go left or right. You'll notice that anything that is positive is going to go to the right. Anything that is negative is going to go to the left. And you learned this in first, second, even third grade, that when you subtract, you're going to go to the left, and when you add, you're going to go to the right. That's going to be something that we're going to continue to use, except negative is going to go to the left. Okay, that negative is the same as subtraction. Now, vertical number lines are going to look a little different. If you have or going in a positive direction, the number is increasing. If you're going in a negative direction, you're going to go down. Now, it's getting winter time and our temperatures are falling, so that would be a representation of a negative number. It's going downward. So that's vertical and horizontal number lines. Let's take a look at how we would use that. When adding integers with the same signs, we need to pay attention to those signs because they're going to tell us whether we need to go to the left or to the right. Because they're both positive, remember, positive is to the right, so that's the way we're going to go. Now, people, depending on how familiar they are with the number lines, have a certain tack, I guess you might want to say, on how you draw. But when in the state of Missouri taking your assessment tests, they're going to be drawn in a specific way. They're always going to start at 0, and they're going to have a little tick mark. And the number closest to the number line is going to be the first term or integer. Depending on whether you're working with negatives and positives or fractions, rational numbers will throw negatives in there too. Let's just stick with this, okay? So our first term is 3. And we're just going to kind of go 3 spaces to the right. You're going to want to put an arrow at the end of that number, or the end of the arrow, to show the direction that it's positive. I always like to put the number on top, just in case I either go too short or too long. I can convey what I'm really trying to do here. Now, the second number is 5. And so I'm going to put a little tick mark right where I ended with 3, and I'm going to go 5 more spaces. Now, sometimes you might want to count to know exactly where you're going to end up, but I know I'm going to end up right here. And so if I look at that and I go straight down, my number is 8. So if I go 3 units to the right, and then 5 more units to the right, I'm at 8 on my number line. So I know a positive 3 plus a positive 5, or 3 plus 5 is 8. Let's try it with negatives. Remember, negatives are going to go to your left. I'm going to use a red arrow this time to help you see that it's negative. So I'm going to put a little tick mark at 0. I'm going to go 3 units to the right. I'm always going to put an arrow to show my direction, and I'm going to write a little -3 on top. My next number, because it's the same sign, is a -4, so I'm going to start where I left off, and I'm going to go 4 more units to the left. That's going to be -4. Now I'm going to put a little line so I know where I'm at in the number line. I know this is 5 right here, and I'm going to go 2 spaces over, so this is going to be -7. Always double check your negatives, because I know when I'm working with my algebra students, I always check those first, because that's usually the first mistake you're going to make. So check those negatives. So I'm at -7, so I know my -3 plus another -3, because I'm continuing down the number line, is going to be equal to -7. Well, what if I have different signs? So let's show an example using 5 and -3. We're always going to start at 0. 5 units to the right, I'm going to go to the right. I'm going to stop at the number 5. Now, I'm going to write number 5 on top. I'm going to start at number 5, and I'm going to go 3 units to the left. Now you'll notice where I end up on the number line is 2 spaces to the right of 2. Let me erase that because that looks like a negative. And so 2 spaces to the right of 0 is going to be +2. Always pay attention. Have I passed the 0? Am I on the negative side, or am I still on the right side, the positive side? One thing I do want you to notice is this area right here, which is -3, and part of the +5, they cancel out each other. This is called a 0. In algebra tiles, I call it a 0 pair, where they cancel each other out. So that tells me that once I cancel that part of the 5 out, what's left of the 5 is going to be my answer. So that's going to be 2. So 5 plus -3 is going to be a +2. Let's try one more example very quickly. 9 plus negative 4. Remember, we're going to go 9 spaces. 9 spaces to the right. We're going to stop at 9. And then we're going to go 4 spaces back to the left. And this is where we end up. It's right at the number 5. So 9 plus negative 4 is positive 5. Notice this again, this portion right here cancels each other out. That creates my 0. And that now leaves me with 5 left over. So 9 plus negative 4 is 5. Your turn, very quickly. 3 plus negative 5. How many spaces to the right? I hope you said 3. Now, how many spaces to the left? Remember, they're different signs. Positive to the right, negative to the left. We're going to go to the left 5. Notice I passed 0. Here's where I landed. So I'm at negative 2. Notice this portion right here that creates my 0. And this is how much I have left over. I'm 2 spaces to the left of 0. So that represents my negative 2. Now let's take a look with algebra tiles. I always like algebra tiles because they're a little bit easier to see. Anything that is yellow or a color, some algebra tiles are green, some are blue, it all depends, are going to be positive. And so I've already put out the algebra tiles for you. Notice I have 4 positive and I've placed 7 positive. Now I always put them in groups of 5 if I can, so I can count them easily. I don't have any zeros. I don't have a negative and a positive. That's going to be a 0 pair. Because I don't have any zeros, I'm going to add them all together, and that tells me 7, 8, 9, 10, 11. That tells me I have 11 total tiles. So they're all the same color, they're all positive, so that's going to be positive 11. So let's take a look at what would a negative look like. Negatives are going to be red, and so I have negative 3 here, and I have another negative 3. Again, I don't have any opposites, so they're not canceling out or creating a 0, so I'm just going to add them up. So 3 plus 3 is 6. Remember, those are red or negative, so my answer is negative 6. So let's try it with different signs. Now you'll notice with this 9 and negative 3, I have some opposites. And right here are our opposites, and this is called a 0 pair. When you get good at negatives and positives or integers, you always kind of think of 0 pairs in your head. How many of one number cancels out the other, and then what do I have left? So here's a 0 pair, here's a 0 pair, here's a 0 pair. They cancel out. What do I have left? I have 1, 2, 3, 4, 5, 6 positives, so that means 9 plus negative 3 is equal to positive 6. Remember, these cancel because they equal 0. So let's take a quick look at another one. Negative 4 and positive 12. Do you see any opposites? I do. So here's a 0, here's a 0, here's a 0, here's a 0. Because they're opposites, they cancel. Remember, I like to group things in 5 so they're easily to count. Here's 5 here, here's 2 here, and here's 1. So I know 1 tile plus 5 tiles plus 2 tiles. Well, this is 7 plus 1 more. I know that's 8. So negative 4 plus 12 is going to be positive 8. Notice my leftover tiles are positive, so I don't even have to worry about my sign. That's it for today's lesson. Let's take a quick review. When adding integers using a number line or algebra tiles, make sure you're looking for things that cancel. When you're drawing a number line, make sure that you're starting at 0. Positive goes to the right, negative goes to the left. Look for the 0 pairs in algebra tiles. That will tell you what cancels, and anything left over is going to be your answer. Double check those negatives. Don't want to lose those, because if you don't place them there, we assume it is positive. Thank you for joining me today. It's been a pleasure having you in class. My name's Mary Jo Fender, and I'll see you next week.
The desire to create lives within each of us. From Grammy-winning producers and musicians, to NBA stars, to Navy admirals and Medal of Honor recipients, to internationally renowned artists and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
Hello, my name is Marcelina Lirius and welcome to Math Monday. In this video, we're going to focus on the Algebra 1 standard on interpreting functions, which is A1-IFA2, use function notation to evaluate functions for inputs in their domains, and interpret statements that use function notation in terms of a context. So before we get started, please be ready with your supplies. You will need your pen, your notebook, and if you have a calculator, that would be helpful. Okay, let's start. When we say function notation, we have the notation y is equal to f of x, wherein x is the input, y is the output, and the name of the function is f. Okay, so if we have y as the output, x here is the input, which we also call as the independent variable. Y is the dependent variable, and the function, the name of the function is function f. Okay, that's the function f. So in our previous videos, we have seen the equations. Let's say y is equal to 5x minus 3. If we use function notation to represent y is a function of x, or y is equal to f of x, is equal to 5x minus 3. So notice that this function is expressed in terms of the variable x, which is the independent variable. Okay. Now let's move on to evaluating functions. So given f of x is equal to 5x minus 3, we are asked to find the value. Evaluating means find the value of the function when the variable x is 2, or when the input is 2. So we have f of x equals 5x plus 3. So we find the value when x is 2. So we're finding f of 2. So replace x with 2 in the function, then plus 3. So our f of 2 is 5 times 2 is 10 plus 3. Then our final answer is 13. So f of 2, or the value of the function when x is 2, is 13. Okay, next. So when we are asked to evaluate the function when x is 1/5, okay, x is 1/5 here. So this simply means that we substitute, okay, in the function f of x, so that means x is 1/5, is 5 times x. So our x is 1/5 plus 3. Okay, so this is our 5 times x plus 3, and that is the function value when x is 1/5. So simplifying, so we know that 5 over 5 is 1 times 1 will give us 1 plus 3. Then the function value is 1/5. I mean, function value when x is 1/5 is 4. Okay, so that's the value of f when x is 1/5. Okay. In our next example, we're going to interpret statements that use function notation in terms of a context. So an online face mask company's monthly production cost is represented by the function cs of x equals 7,000 plus 1.75x, with $7,000 as the fixed cost. And the company also spends $1.75 for each mask that is produced. So this is the variable cost or the production cost per mask. So we are asked to find the total cost if 20,000 masks were produced in October. Okay, so if the total cost is 20,000, so cs of x equals 20,000. So a middle school debate team sold cookies as fundraiser for their trip to Washington. The function piece of x equals 12x minus 15 was used to determine the profit P from selling x boxes of cookies. So we are asked, what does piece of 100 mean? So remember that piece of x is the profit function. So when we have piece of 100, okay, this expression piece of 100 tells us the profit, okay, this is the profit when 100 boxes of cookies are sold, okay, 100 boxes of cookies are sold. That's how we interpret piece of 100. Then in letter B, we're asked how much profit. So if we have piece of x is equal to 12x minus 15. So we're asked how much profit, okay, what is the amount of profit if 300 boxes of cookies were sold. Okay, so the profit is equal to 12. When x is 300, we substitute x with 300, then minus 15. And if we simplify this, okay, help me out on the computation, please double check. 12 times 300 is 3,600. Bring down, okay, minus 15. And simplifying, this will give us 3,000, okay, 585. So our interpretation, the profit earned, okay, when x is 300 is $3,585. Okay. In letter C, we're given that the team earned a profit of $2,385. So we're already given the profit, 2,385. This time we are asked for the number of boxes of cookies that were sold. So what is X? So our profit function is piece of X equals 12X minus 15. So when the profit is 2,385, we are asked for X. Then minus 15. Solving for this equation, we eliminate minus 15 by adding 15 on both sides. And this will give us 12X equals 2,400. Please double check my computation. And by inverse operations, again, we divide both sides by 12. This cancels out. 12 over 12 is 1 times X will be X. And 2,400 divided by 12X is equal to 200. Our interpretation, again, so when X is 200, that means the profit earned by this team is 2,385. Okay, let's have another example. An online face mask company's monthly production cost, C, is represented by the function C of X is equal to 7,000 plus 1,000 plus 1.75x, where 7,000 is the fixed cost and the company spends $1.75 for each mask that is produced. So we are asked to find the total cost if 20,000 masks were produced in October. So if our C of X is equal to 7,000 plus 1.75x, and when X is 20,000, so that means our function notation is C of 20,000 is equal to 7,000 Okay, let's have another example. An online face mask company's monthly production cost is represented by the function C of X is equal to 7,000 plus 1.75x with 7,000 as the fixed cost, and it spends $1.75 for each mask that is produced. So for letter A, we're asked to find the total cost if 20,000 masks were produced in October. So given C of X equals 7,000 plus 1.75x, we are asked what is the cost when X is 20,000. Okay, so using function notation, so C of 20,000 is equal to 7,000 plus 1.75. Again, we substitute X with 20,000 here. Simplifying, so if you have your calculator, help me out with this. If you multiply 175 times 20,000, double check my computation here. So this should give us 35,000. And this means that the total cost of producing 20,000 masks denoted by C of 20,000 is $42,000. Okay. You can take down notes. In the second example, in the second item, we're given that if in September the company spent $33,250, how many masks were produced. So we are given that the cost C is 33,250. So this means that we just equate the function. This is 7,000 plus 1.75x. Okay, then we solve for x. So we're going to subtract 7,000 from both sides to eliminate 7,000 here. And this will leave us $1.75x on one side. And here it will be 26,250. Again, please double check my computation. By inverse operations, we solve for x by dividing both sides by $1.75. And this gives us now x is equal to 15,000. So this will be the number of masks that will be produced if the company spent 33,250. This ends our session for today, and I hope to see you next week.